A freight train running at 50 miles per hour somewhere in Ohio, 150 cars stretching back nearly 2 miles, and the engineer sees something on the tracks ahead. He grabs the emergency brake handle and throws it all the way down. And in that exact moment, a clock starts ticking that most people have never heard about. The brake signal leaves the locomotive and starts traveling backward through a pipe that runs the entire length of that train. And here is where the math gets ugly, because that signal is moving at 500 feet per second through that pipe, which means for a train this long, it will take 30 seconds before the last car even knows it needs to slow down. 30 seconds where the back of the train is still pushing forward at full speed while the front is trying to stop. And every single one of those cars in between is getting squeezed like an accordion being crushed from both ends. That bunching is called run-in, and it can snap couplings, buckle cars, and throw an entire section of train right off the rails before the engineer even understands what went wrong. That braking system was patented in 1869 by a 22-year-old inventor named George Westinghouse. And if you think 150 years of progress must have replaced it by now, you would be dead wrong. Before Westinghouse came along, stopping a freight train required actual men running across the tops of moving cars in the dark, in the rain, in the snow, turning brake wheels by hand one car at a time while the train was still rolling underneath them. They called these men brakemen, and the railroad industry considered them expendable in a way that is difficult to comprehend today. When the engineer blew the whistle for down brakes, these men would scramble across icy rooftops, jumping from car to car, cranking those wheels as fast as they could while ducking under low bridges and dodging smokestacks in tunnels filled with coal fumes. In the 1880s, about 1,000 of them were losing their lives every year just trying to stop trains, and another 5,000 were getting mangled so badly they could never work again. You could recognize a veteran brakeman by his hands, because most of them were missing fingers from getting caught in couplings or thrown between cars while trying to link carriages together. The annual casualty rate for railroad workers back then was 8 per 1,000. And out, which was more than double what coal miners faced, and coal mining was considered the most dangerous job in America at the time. So when George Westinghouse figured out how to use compressed air to apply brakes from a single control valve in the locomotive, it was genuinely revolutionary, and Congress eventually made it mandatory with the Railway Safety Appliance Act of 1893. The railroads fought that mandate for years, claiming it was too expensive, too complicated, too unnecessary, and they only complied after 2 deadline extensions and the threat of massive fines. By 1905, 2 million freight cars were running on Westinghouse brakes, and that basic system, with some modifications, is still what American trains use today. The problem is that the system has a fundamental limitation built into its very physics. One that Westinghouse himself could never have anticipated, because trains in 1869 were maybe 20 or 30 cars long at most. When you apply the brakes, the signal has to travel through that air pipe from the front of the train to the back, and it can only move as fast as sound travels through compressed air. On a short train, maybe 40 or 50 cars, that delay is manageable and most engineers can work with it. On the monster trains the railroads run today, sometimes 200 cars long and stretching 3 miles from locomotive to caboose replacement, that delay becomes a serious hazard. The front cars start slowing down, while the back cars are still pushing forward with their full momentum, creating forces that can buckle the train, snap couplings, and throw cars off the track in what engineers call a run-in. Yet there is a technology that solves this problem, and it has been available for over 30 years. Electronically Controlled Pneumatic Brakes, or ECP, use an electrical signal that travels at the speed of light instead of an air pressure wave traveling at the speed of sound. Every car on the train receives the brake command at the exact same instant, which means the whole train slows down uniformly without all that bunching and buckling. Tests by the Federal Railroad Administration showed that ECP brakes can cut stopping distances by 40 to 60%, which on a 100-car train at 50 miles per hour means the difference between stopping in 4,000 feet versus 2,500 feet. That is nearly a third of a mile saved on every emergency stop. Norfolk Southern, In the railroad that just had that massive derailment in East Palestine, once published materials praising ECP brakes for their potential to reduce stopping distances by 60% over conventional systems. They knew exactly how well the technology worked. The Association of American Railroads helped develop the technology in the 1990s and tested it extensively. Australia uses it on their heavy-haul iron ore trains. Canada uses it on coal trains through the mountains of British Columbia. The technology exists, it works, and everybody in the industry knows it works. So why are American freight trains still running on an 1869 air brake system when a safer alternative has been available for decades? The answer involves $654 million. That is how much the railroad industry spent on federal lobbying between 2002 and 2022, and a significant portion of that money went toward fighting any requirement to install ECP brakes. In 2015, after a series of oil train explosions and derailments, federal regulators issued a rule requiring ECP brakes on trains carrying highly flammable materials. The railroad industry responded with 47 lobbyists from Norfolk Southern alone, plus advertising campaigns, plus lawsuits, plus pressure on friendly members of Congress to delay and water down the requirement. They claimed it would cost $3 billion to implement, which happens to be roughly 2 weeks of operating revenue for the major freight railroads combined. The regulation was repealed in 2018. And the government analysis used to justify that repeal turned out to be missing some important numbers. An Associated Press investigation found that the Department of Transportation had accidentally left out up to $117 million in estimated damages that ECP brakes could have prevented. They acknowledged the error after it was discovered, issued a technical correction, and then said it did not change their decision to cancel the requirement anyway. Meanwhile, between 2011 and 2021, the 7 largest freight railroads spent $191 billion on stock buybacks and dividends to shareholders, which was $53 billion more than they spent on capital investments in their own infrastructure. When an industry association presented slides to regulators explaining why they should not have to install ECP brakes, one of the slides contained a sentence that tells you everything you need to know about their priorities. It said, and this is a direct quote, "If there were business benefits that outweighed the costs of ECP brakes, industry would have installed ECP brakes on a widespread basis." So here we are in 2026, and somewhere right now, there is a freight train running on the same basic braking technology that George Westinghouse patented when Ulysses Grant was president, and the engineer in that locomotive is hoping he never has to find out whether 30 seconds is too long to wait for the back of his train to start slowing down.